Hello, in the second of our Git videos, we're going to have a look at the day-to-day process whereby we as developers can introduce changes and share those changes with the rest of the team, and likewise we can pull down whatever changes the other team members have made and integrate them into our particular code base. So this is very much about day-to-day collaboration. Now, in terms of where we're taking off or starting from, so this is, as mentioned, it's the second part. So in the first part of the video, we looked at getting things set up. So we had two users, a user 1, a user 2. User 1, he or she created the project and then shared it up on, we were using GitLab as a way of sharing the project in this course. User 2 then checked out from GitLab. So both user 1 and user 2, they have their own local Git managed repositories, and they're sharing their changes through the GitLab server, through a shared project up on that. So what we want them to do now is to sort of simulate the process of updating these and then of sharing our changes. So we're going to start off first of all with just reminding ourselves actually how the thing runs. So if I were to push this up onto the emulator, and again we'll be modifying this particular one where we could fly around our spaceship, there's some asteroids. So that was the context. So let's assume that in user 1 we wanted to modify some of these things. So let's make the asteroids actually a lot bigger, and we'll also, for good measure, make them rotate in one direction a bit faster as well. So you can see we've got a blue highlight now to our file, so it's indicating that we've made some local changes that we've yet to commit to our local master. I can just push these up to the emulator to make sure that we have the things running. And there we go, we got much larger asteroids, as we can see. So what we're crudely doing here is simulating the process of making local changes, of testing those changes and making sure we're happy with them. Whenever we do get to a point where we're happy with them, we want to commit them. So these are saving them locally. And this basically says that I've introduced new changes, I've tested them, they're working fine, so I want to commit them into my local repository. Now I'm going to take out this one here because I don't want to have the MISC file as one of the IDE ones. So we're excluding this. And I can put in a comment here that so made asteroids larger and rotating faster. Okay, so that's just a reflection of what I've done. Commit the thing out. So it's now added in. So I've excluded a file, and I do want to add this into my ignore list. And I'll keep that particular one, existing change list. So I'm not going to be asked again to commit that one. So I've made one change. If I was happy with it, I committed it in. Let's just change another one for the sake of it. Make the player accelerate or have a higher acceleration. Again, it turns blue. Assuming I've tested and I'm happy with the changes there, I can commit this change. And we'll say here, player can move faster. And we'll commit in that particular change. So both of these are added in, and I can actually, you can see these if you go down to the version control log at the bottom, different things here, but you can go to the log. So it shows us that on the origin, up in the server, we did our initial commit and we pushed up all of those files. After that, I've done a couple of local commits. So I've one here about updating my asteroid, and my current head at the top of my local master is this particular version here. So what I'm doing there is I'm representing that I, as developer 1, are updating and progressing the project. Now, so far so good. Let's assume that whilst I'm working on it as user 1, we also have user 2 working on the project at the same time. So this is what teams do. People work concurrently. So we'll go over now and we'll have a look at user 2. And you'll notice here that we have changes then. So for example, in the asteroid class, I updated it here, but inside player 2's asteroid class, we can see that it is the original 50/50 as opposed to my updated 200/200. And indeed, under version control, if I go to log, I've only got my initial commit where I pulled things down from the origin. So we've got two different users and two different timelines effectively working alongside. So let's we'll update another one here, say the AI spaceship, and we'll change. This is a bit of behavior at the bottom that determines when a collision is imminent, how strongly you react to that collision. So I've now changed that so that it reacts more strongly to it. Again, I would assume I would be happy. I would test all of these. Whenever I get to that point, I can then commit up my changes. So this is user 2 committing changes. Again, I'm going to exclude this silly file. And AI ship now better avoids collisions, and commit to that particular change in. Oh, I'm going to take off the perform code analysis and the to-dos. So commit this in, and I'm going to add that into the default changes. I don't have that as well. Okay, so there we can see we have a situation where user 2 has added in a change to AI spaceship, and user 1 has added in a change to a couple of other files. Both users working independently on their own local repositories, quite happily making changes, checking to see that they work, and getting on perfectly fine. Now, this is where it gets interesting, because let's assume we've got to the point where user 1 and user 2 are saying, I'm happy with the changes, I've introduced some nice features, I want to share these with the rest of the team, so the rest of the team can get access to all of the lovely new code that I've put in. So this is where we're having then to push up onto the origin, onto the GitLab server, the changes that we've made. And this is where it does get interesting. So there's a few things we'll always want to do here. So let's assume we're doing it initially from user 1's point of view. And user 1, just to confirm, you only ever do this whenever you're happy with the local changes. You've got something, it's up, it's running, it's working, you're 100% okay. You do not want to share rubbish code with the rest of the team. You do not want to share something that will break the build with the rest of the team. So you're only going to do this whenever you're standing over the code that you've done, that you're happy with it. But let's assume that's the case. So now what we want to do here, first of all, is that I've got to check. So I want to push something up. I want to share my changes. Now, I will have based my changes on a version that I pulled down at some point in the past. So I pulled down a version from the repository. I've made some changes to it. I want to push it up to share it. It is possible that since the time I pulled it down, somebody else has uploaded new stuff. And that new stuff has been uploaded onto the origin. So I want to check to see, has anybody updated the origin since I pulled down from it last time? So this is, are there any new changes up there that I need to take into account before I can push up my changes? So it's very important to do that, else I'll be pushing up things which could be out of date. So inside version control, I can go into update project. An update project is going to say, okay, I've been working locally in my own repository, compare what I've been doing against the origin, the online one, or GitLab, and check to see, has anybody else added any new stuff that I should pull down to use? So update project under version control will give me a number of options, and this is potentially a bit of confusion can come in at this point. So whenever we're thinking about Git, there's a couple of different ways you can update. You can merge or you can rebase. Now, update project, you got a branch default. This is something that Android Studio has built in, and that just goes with the default one you define for the project. But I'll talk you through merge and rebase. And I would suggest you do a GUI on these, because you'll find a lot of debate about some people favoring one, some people favoring the other. They're somewhat similar in their functionality. They differ a bit as well. Now, in essence, for merge, what merge says that if you have two people working in parallel, making commits and changes as they go along, merge takes all of these commits and changes and puts them together into a sort of a combined timeline. So you will have, inside the log, you will see your commits and the other person's commits and your commits and the other person's commits. So both of these things are sort of combined together. Rebase is a bit different. It says that if, since I pulled down my copy and I've been making changes, somebody else came along and updated it, well, take down their changes first of all, put them in, and then add my changes on after it. So it doesn't mix the two together, it sort of redoes all my commits so that they appear after the other person's commit. So it's subtle differences in terms of doing this. In terms of rough rules of thumb, if I, since I took it, my last copy down, since I pulled it down from the origin, if I'm adding in a new feature, and that feature is complete, so I haven't shared it with anybody, I started it and I've completed it, so it's a brand new feature. That's a good scenario on which to rebase it. So to take the latest thing that you have online, even if somebody's updated it, and to add my changes on top of that latest version. Merge, I would use that if, let's say I was adding in a new feature and I got the feature half done, so it was kind of working but not complete, and I then pushed that up and I shared it with the rest of the team so they could see the new feature. In that case, I've kind of got half of my feature already out there, I want to add in the other half. It's better in that case to use merge, because I'll combine it in with whatever I already put up there. So it swings around about. Like I said, do a Google of this in terms of the one you want to do. I'm going to assume rebase here, under the assumption that I was adding in new features, I wasn't sort of partially doing things. So I'm going to update my project, and I'm going to say that if there is any changes I have to integrate down. Now there isn't for this one because I'm the first person to add to the repository from our original commit. But if there was, I would use the rebase rules for how we combine those. So I do OK, and you've got some text then appearing down at the bottom, and all files up to date. Okay, so it's had a look. There isn't actually any change to the repository, so that's fine. I have the most recent version. So, okay, good. Now, having done this then, I'm content that my project is up to date and I've got my changes. So I want to then go down to Git and to push those changes up. When I do that, I get another message and it's saying I'm going to take my local master, I'm going to go to the origin and update the master in this, and I'm going to pass in, or to push up, these two changes. So that's what I'm adding into the master, the online version. So I can push that up. Then you get a bit of text appearing at the bottom has been pushed up. If I were then to go into my virtual, this is the GitLab on side and the repository, actually commits, you can see I now have a number of commits against it. So I had my initial commit, and then 9-10 minutes ago I made a few other local commits, and I've now pushed those up. So these are actually visible on the server. So all of the team members, if they're looking at in this case, the Gedge project, into the repository, the commits, they can see these. In fact, if they actually click on one of them, they can get a window appearing. You can either do it in line or you can do it side by side, that shows me that, okay, well, it was 300 originally. That particular change is then updated to 600. So people can view what change has been made either by themselves or by the other team members. So this is good. So user 1 in this particular case has made changes, has checked to see if there's any updated, and has then pushed their changes up. Brilliant. So now what we want to do is, actually just before we do that, so under the log then, we can see we've got the log updated. We had our initial commit. Now the most recent one is the origin, the master. It's the master of the local copy, so this is by far the most up-to-date version. Right, now let's do the same then for the second user. So the second user, they want to share their changes, so they changed how the AI was working. They'll do a similar process. We're going to VCS, got to update our project to see has anybody else changed it since we did it. So we've got a similar window. We're going to do rebase. Now, here's the thing. We do actually have changes here. So user 2, they were basing on the original copy. But since I've updated my AI player spaceship, or AI spaceship, user 1 has come in and they've pushed up their changes. So they've updated the asteroid and the player. So in this case, I will find that the copy that I have has been updated online. So we're going to do OK in this case. And we'll have something. So actually, you can see down at the bottom, we now have different activities appearing in terms of rebasing it, and this is where it reworks out and combines and pieces together all of the different bits. So we have a coherent history, and inside our version control, if we go to the log, we can now see in this case that admittedly I'm the person doing all of this, but you could see a different person's name against this if it was another team member who did it. But there we're bringing down the other aspects. So the origin master is now updated to include the changes that user 1's pushed in, and then user 2 is adding in his or her changes to that. So I've rebased it, I put my changes after the updated changes. So now that I'm happy is up to date, I can do same as before. I can push up my changes. So user 2 says, okay, better avoids collision. Let's push that up. That then goes up onto the server. And if we were having a look in here in our list of commits, we've now got this appearing as well. So far so good in terms of both users being able to push these things up. Now let's look at a more complex scenario where we have a conflict. So we're going to have a situation which ideally should be avoidable, where user 1 and user 2 are going to change the same piece of code. So this represents sort of a miscommunication, which ideally we would want to avoid. So let's say they've both had a team meeting, and it was decided at the team meeting that we would change the size of the asteroid again, that they were too large. So both user 1 and user 2 left the team meeting and they thought, I'll make that change. So this is maybe how communication problems can arise. So let's look at it from user 1's point of view. User 1 goes back and user 1 says, okay, I'm going to add in a new feature. In this case, it's going to be changing the asteroid size. So what user 1's going to do is, before they're going to start adding in that new feature, they're going to update their project because they just want to make sure they're using the most recent version available. So I'm going to do update, I'll do rebase in this case. And actually in that case, this is where user 1 will find, oh look, since I last committed my changes, somebody else came in and updated, in this case, the AI spaceship. So there, we now know inside our log that the version that we have checked out here is the latest version in the origin as well. So that's a good starting point. So let's say asteroid half width, let's change it to 200. And let's assume we do a similar thing here. We would be updating our project just to make sure we have the most recent version. Now, user 2 will have the most recent version, so there'll be no changes. We're going to asteroid, and let's say they change it to 300, so they thought a different size. So again, we're making the changes. We would test them locally. We're going to commit them locally. Asteroid resized. And we change that, let's say, to 300. And we will commit that change out. And over here, user 1, he or she checks it, happy with the changes. They're going to commit their changes locally. And asteroid size, I'm going to put 200 just so we can differentiate between these, and commit it out. So both user 1 and user 2 have made that change. And they now want to say, brilliant, I've updated this new feature. I'm going to share it with the rest of the team. So so it's a question of who gets in first. So let's assume user 1 gets in first. So user 1 says, right, I want to share this with the rest of the team. So I'm going to update my project just to make sure I've got the most recent version. I will have. I'm then going to push this up to share it with the rest of the team. So I'm going to resize it to 200 and push that up. And again, inside here, inside our repository on the commits, these things are appearing. Now let's go to user 2. Now user 2 is going to update the project as well. This is going to be problematic because whenever we update the project, we will go online and we will check to see, has any of the files changed from the version I have here. We're going to detect that online asteroid has changed. And whenever we look at the changes in asteroid, we're going to realize that the origin version has a half width of 200. And it's going to be smart enough to realize that, oh, I've made a local change here to say that it's 300. This is a conflict. So in user 2, the changes that they have made conflict with the changes that are on the origin. And that's something we're going to have to deal with. Now, Ideally, you should avoid these things, and good communication and teamwork will help you avoid them. But let's just do update project. We'll say we'll rebase it, and we'll do OK. So it's going to go checking these particular aspects. So stashing the changes in, rebasing the changes, and now we've got a merge conflict coming up. So it's detected that, hold on, there's something not quite right here. So how do we deal with this now? It's not necessarily intuitive from this dialog. This dialog seems to say you can accept my change, we could accept the other change, or we could merge them together. Now, the thing about this here is if you double click on that, you will actually get to see what the differences are. So double click in any merge conflicts and I'll show you what they are. So over here, I've got my local changes. So local changes is where I had 300. Over on the right-hand side, we've got the updated version in the server, where it's 200. And in the middle, you have the original version, where it was 100 before it got updated on the server, and then before I updated it locally. And I can choose which one I want to replace it with. So I'm going to replace it with my version, or rather user 2's version. So there I've said for this particular merge conflict, I'm going to go with my one. Fundamentally, well, that's a way of resolving the merge. Fundamentally, this is not ideal, because user 1, I'm going to have to go and tell them that actually there's a merge conflict and I changed to my value. And then user 1's going to have to take that into account in terms of, does this break anything else they were doing? Has this changed their assumptions? So ideally, you want to avoid these things by making sure the team has good communication and knows where everybody's working at. So if I apply this, do you want to change this and finish merging? Yes. So there we go. This will give me a value of 300 in terms of the local one, and I can then, it's the same things as before. I can say I'm happy with this. I want to push it up and share it to the rest of the team. Whenever user 1 comes in and they update, they will bring down a value of 300 because that was the one that was resolved in terms of the conflict. And so we carry on. So that's all we want to cover at in terms of this particular video. It's important that when you're using Git then, a couple of key things. Any changes that you're making and committing locally, need to be sure that you've well tested them and you're happy with them, that they're good quality, robust code. Anytime you want to share your changes with the rest of the project, it's really important to check to see has the project been updated since you introduced your changes. So you always update your project. Hopefully that won't result in any merge conflicts. If it does, you need to resolve them. But once you've updated your project, you can then push up your changes and share it with the rest of the team. Anytime you're introducing a new feature into it, so you're going to be updating the code, always again remember to do an update to make sure you're starting from the most recent version. And as long as the whole team adheres to these reasonably simple processes, and you get very routine after a while, everybody will be able to collaborate nicely together to share their code. And the nice thing about the GitLab and the other ones is you can view all of these changes online. You can see what people are doing. You can revert back. You can do lots of different things with it. But very much this is the bread and butter sort of update and push and pull associated with it. Thank you.